Good morning, everybody. How are you doing? Great to see you all here. I am Tad Brockway, and I'm going to be talking about Azure Storage. I'm responsible for a portfolio that includes all aspects of Azure Storage, our media platform, our edge platform areas like Azure Stack, Databox. We'll touch on some of those things. But the focus for today is to give you an update on all the great work that has been delivered in 2019. In fact, 2019 is our biggest year in terms of just the quantity of features that this team has shipped. We've shipped more features in 2019 than any other year, going all the way back to 2010, which is when we GA'd the product area. So we're proud of the work that we've done. We believe that we're delivering strong and unique, differentiated customer value for all of you. We'll talk about the announcements for the show, the Ignite announcements, and then we'll do kind of a refresh of everything that's been done in 2019 so far. And I have here with me my friend Yui Min. She's going to be helping out with some demos of that technology. All right, so before we get into some of the details of what we've released, let's just do a quick refresher on what is Azure Storage. Azure Storage is it's a big umbrella of services and product areas that is the durability layer for Microsoft overall. And it's our unstructured data platform for the entire company. All of our first-party services, all of our like Xbox and Teams, they all build on top of Azure Storage. And then, of course, it's the foundational layer for the Microsoft Azure platform as well. Within Azure Storage, we have our disk storage set of services. That's our block storage solution for the product. And then we have file storage, which includes Azure Files and Azure NetApp Files. Those are our shared storage or shared files aspects of the product. And then we have object storage, Blob Storage, which is our object storage petabyte scale service. Now, with respect to all three of these areas, we've made pretty dramatic improvements in 2019. Just some quick highlights. In the case of object storage, we integrated in Azure Data Lake Storage Gen 2 as part of this calendar year. It's a very powerful combination of technologies. And then we shipped Azure NetApp Files, which is the only managed NetApp Files service on the planet. So that's part of our platform as well. And of course, with these great services in the cloud, you need the ability to get your on-prem data assets. You need to be able to get them into our platform. So we have a couple of hybrid and data transport technology areas. Databox gives you the ability to order up a physical appliance from our website. We'll ship that appliance to you. You can fill it up with up to nearly a petabyte of data. Ship that back to us. Comes in a bunch of different form factors. And then we have a number of hybrid storage solutions as well. These are products that you can run on-prem that act as gateways into the public cloud. The Azure Storage Platform, what makes it just from an architectural standpoint fundamentally unique is that we have the same basic fundamentals across all of these different services that we'll talk about today. The same durability guarantees, 3 replicas for every single service, at least 3 replicas. We will write all 3 replicas before we act back on a single write. That's unique in the industry. Same security model, same availability, scalability, capabilities, all of that's consistent. And then on top of that, we layer a namespace capability, which lights up Azure Data Lake Storage Gen 2 so that we can have HDFS integrated deeply into the object storage platform. On top of that foundation, we layer on multiple tiers of storage from very hot SSD-based storage all the way down to, for long-term data retention, a very cold layer. And then there's lifecycle management so that automatically your data can move up or down these tiers based on policy that you define, so that the economics and the performance of those trade-offs, they're handled automatically for you by the platform. On top of that, we have Azure HPC Cache, just went GA this week, announced as part of the show. That gives you a cache for for your hottest working set data for parallel compute workloads, and that just snaps right on top of all of this, these different storage tiers. And then we expose these storage tiers up through a variety of end user endpoints. We support REST, HDFS, block storage, as well as SMB and NFS file semantics. And then with that, we provide the richest set of hybrid intelligent edge capabilities that connect automatically to this storage system in the cloud. Hybrid, of course, is essential, especially for enterprise customers as you're moving to the cloud, moving your data assets to the cloud on your terms. We have a whole set of offerings in that regard. And all of this, what it does for you as in customers, it enables you to support a number of different workloads that we've grouped into these 4 workload sets that we'll use as a way to guide our way through the rest of the presentation for today. So as you might imagine, we have many customers who are in production with the workloads that we'll talk our way through today. Lots of familiar logos on this screen. And there are customers who have massive volumes of data that are taking advantage of our Azure Storage product area. So the first workload that we'll talk our way through is the application and user data set of workloads. And so this one's pretty straightforward. You can think of application data as being the data for your apps that power your business. The user data associated with those applications, it's all of the user-generated content and data generated by all of your customers, your employees. And then all of that is managed using the Azure Storage system. We have a number of capabilities that we've implemented along these lines. The one that, one that we're very excited about, especially in 2019, is that we have implemented the hottest storage on the planet with respect to all facets of Azure Storage, which is exactly what your users, your employees, your customers need as they're running their most mission-critical applications in the cloud. So we have the hottest tier for block storage with our Ultra Disk offering that recently went GA in August. We have the hottest tier for object storage with our premium Blob solution. And we have premium files that went GA in June with additional capabilities being announced at this show. So let's drill into some of these in more detail. Ultra Disk is our block storage solution for the most mission-critical, highest-end scale-up workloads. Ultra Disk supports less than a millisecond write latency, up to 160,000 IOPS, and it is designed to be certified for HANA and other mission-critical high-end workloads. In fact, Ultra Disk surpasses the strong requirements that are required for workloads like HANA. In terms of our roadmap, we have some new features at Ignite that we're announcing. We have shared disk support for Ultra and Premium SSD. That gives you the ability to run your SQL workloads, and you can run them in HA mode. And we've done that by implementing SCSI shared reservations, so you can have a single virtual machine or multiple virtual machines accessing a single disk. That makes it really easy to manage fast failover of your applications for SQL. In addition, we have the ability to support, just to highlight a few of these, direct upload to managed disks. So you can go from your on-prem disks environment, and it makes those migrations much more straightforward when moving your disks into the cloud. So with that, we'll turn it over to Yui Min. We launched Premium Files in June. Big performance improvements in files with the Premium Files launch, and she's going to tell you all about that.
Thanks, Matt. Let me do the switch. Perfect. So let's start with taking a look of the SQL failover cluster setup. So right now, I'm logged on to my secondary VM. You can see that in this cluster, I have two nodes, the VM1 and the VM2, primary and secondary. Now let's take a look of where the SQL role is installed. It's now running on my primary VM at this point. I would also like to show you where the database files are. So if I switch over, I can see the properties of my SQL database. If I zoom in right here, you can see that both the data and the log files are stored on demopfs account.file.core.windows.net/premium-share1. So this is using a premium file share. We have worked with the SQL team to certify this scenario for production workloads. I have also mounted the premium file share as a Z drive right here. You can see it's the same premium share 1. If I go to the property, this is a 1 terabyte premium file share. So now I have shown you the cluster setup. Let's go and have some fun on this cluster. So I'm going to the primary VM right now. So today is a Tuesday, so assume it's a patch Tuesday. And I'm going to reboot this VM as if I'm doing a Windows update. So right now, the VM is getting rebooted. So I'm switching back to my secondary VM. You can see that the status is pending. We expect the secondary to be quickly selected as a new primary. Actually, you can see that right now, the node is already coming to the secondary VM. So right now, it's back running again. So the failover is super fast as the data is persistent on the premium file share. The secondary can quickly come up and start serving traffic. So what makes premium file share so special in this use case? Let's go and actually take a look right here. So assume that your SQL application is getting very popular. You wanted to scale up your capacity and also your IOPS for higher transaction. So I can easily do that with premium file share. So I'm now on portal. I have the same share selected. I'm going to just click on quota, change it to, let's say, 50 terabyte. I'm going to click OK. Right there, it successfully updated the file share. So a 50 terabyte premium file share can provide you provision performance of 50,000 IOPS and burst up to 100,000 IOPS. And if I check back right here, and I do look at the same share, voila, it's already updated to 50 terabyte. So basically, you don't need to change any of your SQL failover setting. You can scale up your storage 50 times as before, just like this. So I'll hand it over.
Awesome.
Yeah, back
Thank
to
you. All right, so as you can see, Premium Files is now available to you as a powerful tool for helping you to move those on-prem data-oriented workloads over to the cloud. So let's go through and talk about some additional highlights. Here at the show, we've announced support for NFS v4.1 for Azure Files, which is great. And this one I'm very excited about. We have made it now possible for you to take your file shares that you're keeping around for long-term retention purposes, and we've created a cool tier of storage for Azure Files. And this is something that a number of customers who use our Azure File Sync product area have asked for. As they tier their on-prem data assets into the cloud, they want to be able to tier them down to a price point where there are fewer IOPS, but then they want to get some money back and not have to pay so much for the data. And so with our cool tier, we're talking about a 75% savings versus standard storage, which is pretty cool. Okay, so on to Blob Storage. Here's some examples of some customers, some real customer workloads that are taking advantage of this hot SSD-based tier for object storage. We have, through our partnership with Avid, they develop tools. Media Composer is the name of their product that's used for editing movies and TV shows. That requires, those scenarios require very hot storage. Normally, that's not the kind of workload you'd be able to run on top of an object storage system. But through a partnership with Avid, we have Walt Disney Studios, who is now using Media Composer on top of our Blob Storage platform so that their editors around the world, they can get access to editing their content from anywhere on the globe. We have Adobe, who's has picked our Blob Storage platform as their analytics storage solution which they're building on top, which helps them get insights for their customer preferences and so on. And then we have TomTom, who's using premium blob storage for their mapping data. Okay, next workload, backup and archive data. Backup and archive is frequently the entry point for many customers into the cloud. It's the kind of problem where it's really just cloud. It's obvious the cloud is a much better solution than dealing with all the complexities of LTO libraries and everything that just goes with keeping track of your own archive data. But what customers need as they adopt cloud for backup and archive data solutions, they need a cloud platform that has very low TCO. Otherwise, you wouldn't be able to, it just wouldn't make sense economically to move to the cloud as opposed to just dealing with all this complexity of tape and so on. In order to get your data into the cloud, we've talked about the data box family, you need some means to seed the cloud with your data sets. And so that's where DataBox comes in. Like I mentioned earlier, you can order up one of our pretty rich family of DataBox appliances. We have DataBox Heavy, supports up to 1 petabyte. That's the one that's on wheels. We have the regular DataBox, which supports up to 100 terabytes. You order the devices up, fill them up with data, and then they just show up as part of your storage account. We have partners, a number of partners of ours, who are providing turnkey access so that you can have, again, this LTO archive opportunity. They will work with you in turnkey fashion to move your LTO assets into Azure. And then we have our ExpressRoute network-based set of offerings to move data over the wire. We have recently announced something called ExpressRoute Direct Local, which is pretty neat because one of the things that comes with the cloud is there's some uncertainty around egress costs. People see the benefits of getting their data into the cloud, but then they kind of get worried about, well, what's it going to cost me? They don't want to have an unpredictable bill when they draw it back out. That's where ExpressRoute Direct Local comes in. It includes a fixed amount of egress that's available to you and a fixed fee on a monthly basis, so it's much more predictable, and it goes very well with Azure Storage. Now, with respect to this TCO thing and being able to enable LTO replacement in the cloud, we've dramatically reduced the cost of our cool storage platform and our archive long-term offline storage platform. Those are available to you. And in August, we announced a 50% price drop on the archive tier, again, making it easier for you to unlock those on-prem LTO assets. We have a number of partners who have developed solutions for backing up and archiving data from on-prem. If you're one of your backup or archive providers is on this list, they have nice integration with the Azure Storage Platform, and they can make it really easy for you just to bring in your Azure subscription and then get going and taking advantage of our cloud platform. In addition to the ISVs mentioned on the previous slide, we have a couple of ISVs who have developed SaaS solutions in the cloud. These are solutions that software as a service with Veritas as well as Metallic, a Commvault venture, have implemented the ability to just deploy and use archive and backup solutions, really just as straightforward as deploying any other service on Azure. Veritas in particular, they've been running on our cloud for some period of time. They have millions of mailboxes. They support Office 365. And then Metallic is a relatively recent offering from our partner Commvault. Okay, so next workload, let's dig into analytics data. Analytics data, of course, it is relative to backup and archive. It's a relatively new workload that's lighting up in the cloud. And with analytics data, as you know, data, of course, can be vast. It can span many petabytes and exabytes over time. And these data lakes on-prem, they are rapidly moving to the cloud. So if you think of this whole data lake phenomenon and in the consolidation of on-prem data assets into data lakes on-prem, that sort of way of thinking about data, it is much more well-suited for the cloud than it is for on-prem. If you think about it, And so that's something we've invested a lot in Azure Storage to enable that for our enterprise customers. Azure Data Lake Storage Gen 2, we've made significant investments in ADLS Gen 2 in 2019. We GA'd ADLS Gen 2 earlier this year. And what we are announcing at this show is something that really is revolutionary in cloud. It's multi-protocol access. And so that sounds, doesn't sound very compelling, multi-protocol access, but what it means to you is that you can leverage your data, whether it comes in through Blob Storage or through our HDFS endpoint, through ADLS Gen 2, you can enter through either of those entry points, and then you can compute over those data sets using our rich set of analytic services. And so it allows you to late bind your compute relative to your storage. And what it does is it just fundamentally eliminates data silos. So you can have log files, for instance, that are being consolidated into Blob Storage and then computed over using MapReduce services on top via ADLS Gen 2. It's very cool. So now we have a demo. Yuimin's going to show us more about it.
Perfect. Let's switch it over. So what we're going to show you today is that how easy it is for us to actually do on-demand analytics directly against Blob Storage. Let's assume that I work for a car manufacturing company. I would like to collect all the data from my car sensor to do some research. First problem I need to solve is that how do I ingest all these data into a data lake? So Azure Blob REST API will be a very good choice here. So I'm going to show you this short Node.js code snippet. So what it does here is that it directly uploads the data from a local directory and upload it into Blob Storage. So now let's take a look at this. So you can see here, I'm specifying my local file path. So it is pointing to a Parquet file, if you actually scroll to on the side. So this is where my data sets that I collected from my sensor are stored. Next, I'm going to specify the target, which is the service URL that goes to my storage account. You can see that it's going to storageaccount.blob.core.windows.net. So it's accessing the Blob endpoint. Last, I'm going to call into this upload local file. It will directly upload the file from my local directory, my local device, to Blob Storage. And in this case, it uploads this Parquet file into a blob. So why don't we take a look when the data get into the storage account. So here I'm on Azure Portal. I have selected the storage account, which is my target. You can see the list of the Parquet file right here. So it made it greatly into Azure Storage. So now that the data is in Azure, in the storage account, what can we do with it? Our goal is to gain business insights from these data. So traditionally, to do that, you need to build a proper analytics pipeline. You need to extract, transfer, and load these data in a series of steps. Today, leveraging Blob Storage and ADLS Gen 2 interface, you'll be able to run analytics jobs directly against your Blob Storage. I'm going to show you using Synapse. So who attended Satya's keynote yesterday? OK. Then I have a broad audience that all knows about Synapse. Great. So I'll switch to it. So Synapse, if you haven't heard about it, it is a new analytics workspace that is built for data scientists and engineers to work on their data sets. So you can see that right here, I have already loaded my storage account, so the same storage account. You see the list of the Parquet file. What I'll be able to do is that I'm going to show you a notepad that I have built, which has a few queries that I'm going to run against this data set. So the first one I'm going to do is to construct a table. You can see that I'm accessing the data through the DFS endpoint. I'm reading the sensor reading. So the exact same data sets which you uploaded through the Blob API can be seamlessly accessed through the ADLS endpoint. What enables this is multi-protocol support on Blob Storage. So you can now run analytics queries directly against Blob, and is accessing it through the ADLS interface. So
That's awesome.
Yeah.
So without any complex data transforms or migrations or dealing with silos of data, loosely coupled analytics on top of a multimodal, multi-protocol storage platform.
Yeah, exactly.
That's cool.
So it's taking the analytics to the next level. So let's scroll down, and then we can do the real work. So here, what I'm doing is that I'm getting all the vehicles with high engine torque measurements. So I can directly run a SQL query right here. You're probably very familiar with this. We'll go ahead and just filter what is the kind of the recording date, sensor name, and we'll set the reading value to be more than 100, indicating possible issues. So this query will go and return a list of the unique vehicle IDs and also the counts which exceeded the limit. So the results, when it gets returned, you can go and follow up with your customers or conduct deeper analysis to look into possible failure patterns. So we make this very easy for you. Another cool thing about this is that if I go back to my data set, I can just go and select all the data sets I want to work on, click, do a new SQL script. It will directly launch this template, which basically it continues to access the data through the DFS endpoint. So it's very seamless. In this short demo, I showed you how easy it is to run analytics directly against Blob Storage, leveraging ADLS Gen 2 interface.
Wow, very cool. It took a lot of years to get to this point. It's great to see this, honestly. It's very cool. Okay, so with ADLS Gen 2, we talked about how we have a Blob Storage interface, we have an HDFS interface, and so at this show, we're announcing, in addition, an NFS interface. So NFS, especially NFS v3, very popular. It's been around for decades. I'm sure that you have a lot of on-prem storage assets, log files, things like that, stashed away on top of NFS shares. Now you can easily migrate that data into our Azure Storage platform, and then you can run same thing. You can run analytics on top of NFS data. You can run analytics on top of Blob Storage data. So what we're seeing here is years of investment on our engineering team in terms of creating this single storage system with multiple protocol interfaces, now really showing up as something that's just fundamentally unique in the marketplace. In terms of roadmap, we talked about ADLS Gen 2, multi-protocol access, GA here at the show, NFS as well. And then additionally, we've announced, at Ignite, we've announced support for reserved capacity. So if you have large data sets where you have data retention requirements where you need to keep data around for long periods of time, you can buy essentially virtual stamps of storage that you can use, and you get a dramatically lower cost price point for your storage by just adding a little bit of your own predictability into our platform. In addition, we now have support for, this is super important for enterprise customers, support for your local AD environment. You can integrate your local AD in, and then you get all the richness in terms of authentication, authorization, ACL support. All of that is now supported in the cloud as well. So we essentially become an extension of your on-prem environment. That's cool. Few customers to highlight here, Starbucks and Daimler. Starbucks is an example of a customer who selected Azure Data Lake Storage as their unified data lake platform. And then Daimler is leveraging the work that we do with ADLS and Azure Storage as well. All right, so moving along through the workloads, HPC, IoT, and AI data. That's the next one to look at. So we announced GA of a service at this conference called Azure HPC Cache, What Azure HPC Cache does is it sits on top of Azure Blob Storage, Azure NetApp Files, or Azure Files as a layer on top. You just kind of switch it on top of those different storage services, and it exposes from there file endpoints for your hottest, most parallel compute workloads. So you can have an HPC workload, for instance, for something like an oil and gas scenario, or life sciences, or media and entertainment, a rendering scenario, and you can have thousands of compute cores all accessing that same working set, all accelerated via this cache that you turn on when you want to run your batch of compute, and then you turn it off when you're done. We have an on-prem version of that as well. We have a hardware appliance called the Azure FXT Edge Filer, so you can get the same advantages, that symmetry, from the cloud to on-prem, and you can do that with a hardware appliance as well. And then this is a really unique feature. You can leave your storage assets on-prem. Let's say you have a big data lake and you have a bunch of assets that you've stashed away for some HP set of use cases, but you don't have enough compute on-prem for a given batch of a compute workload. What you can do is you can actually run the Azure HPC Cache in the cloud and point it back to your on-prem data assets. So it gives you a cache for your cloud compute, even all the way back to on-prem. Very cool. So we've announced the GA of Azure HPC Cache at the show. Let's look at a demo.
Perfect. So the scenario I would like to describe to you is movie rendering. Let's say I have a movie that I need to get it on the big screen by Christmas. My timeline is very tight. So the plan is to spin up a huge rendering farm so that I'll be able to complete the job in time. I would like to do that in West US too, because I got a very good price on the compute there. However, I have a problem. My data storage are in Montreal. That's where my artists are based on. So all my production files, my media assets are based on an NFS share in Montreal base. So how can I accelerate my storage so that I'll be able to run my rendering job seamlessly? Well, HPC Cache is the solution here. It's able to reduce your storage latency and help your rendering job to run smoothly. With that said, let me show you how easy it is to create an HPC cache on Azure. You can see here I'm on Portal again. So what I'll do is I'll go and search for HPC Cache. You can see it's right here at the marketplace. So I just click on it. It will launch the creation blade. So what I'll do is that I'll provide a resource group, then a cache name. I'll choose the region to be West US2, where it's close to my rendering farm.
And so you can even optimize for where you have capacity that's the least expensive capacity, right?
Exactly. So I'm going to choose my pre-created VNet, and then I'll go here. So the next step is to configure my cache. First, I'll choose the throughput. I would like it to set it to 8 gigabytes per second. Next step will be to choose the size. It is very important to make sure that your active working set can all fit in the cache. So I'm going with the higher size. I'll go 24 terabyte. I'll right now click Create. So that's it. The deployment takes around 10 to 15 minutes. It does all the compute networking, all the Azure resources provisioning through this deployment. So HPC Cache is a fully managed service, so you don't need to do anything or manage any of these management overhead. For the sake of time, I'm going to switch to a pre-deployed cache. So here I have my Ignite demo cache here. Now that the cache is created, the next step is to connect it to my NFS share in Montreal. I'm going to click on Storage Target. So Storage Target is the data volume that you want to accelerate using HPC Cache. I'm going to add a storage target. I'll go with the user-friendly name. I'm going to choose the target type as NFS. You can also choose from Blob. Actually, you see it here. I'll provide the host name. Then I'll choose the usage model. So I'm going to go with read-heavy infrequent writes because this is for a rendering workload. So you can choose whichever that applies to your workload. Lastly, I'll provide the virtual namespace that will map to my NFS export path. I'll click OK.
Do you have a typo? Oh, that's all right.
I'm good. Yes, okay. I thought I'm doing a spelling, a typing test. So it's getting connected to my storage target. If you see here, I have already connected this cache to 2 targets. The first one is a Blob Storage one. So you can see here it's connecting to my storage account, which a Blob container right here. My next one connects to an Azure NetApp file. So it's going through the NFS target. What is great about HPC Cache is that it gives you this flexibility to connect to multiple different targets. Your target can be on premises, on Azure, it can come through with Blob, or it come through NFS endpoint. So we give you this flexibility to accelerate your storage, no matter where it is. So now I'll switch it back to Ted.
Okay, thank you. And so essentially it removes the latency, right?
Exactly,
in a nutshell,
yes.
Right? So you could have milliseconds of latency from your compute in one of our public regions,
yep,
all the way back to some NAS device in one of your sites,
yep,
and it just takes away all that latency automatically.
Exactly.
So very cool. All right, so next area, Azure NetApp Files. Azure NetApp Files, how many of you are NetApp customers today? Okay, so Azure NetApp Files will enable you to run all of those Azure or all those NetApp workloads in our cloud. And so we have the only solution in public cloud today where we have NetApp on tap in our data centers. And we've worked with NetApp to create a network that goes from Azure virtual machines to NetApp on tap, and that network is fast and it's pristine. And we've heard from some customers that they're getting even better performance in the public cloud by using NetApp with our virtual machines than they would get on-prem, just because the network is so capable. So this is a great way if you have workloads, HPC workloads, virtual desktop workloads with the new Windows Virtual Desktop Service, support for containerized applications, HPC workloads in areas like semiconductor, EDA, oil and gas. All of those workloads will work at least as well as they do on-prem in the public cloud. Of course, then you get all the benefits of a fully managed cloud service. Instead of having it take days or even months to provision a new ONTAP volume, you can literally provision a new ONTAP volume in Azure in less than a minute using your Azure subscription. Very cool. A couple examples of some workloads. BP has chosen and they've deployed Azure NetApp Files as their default storage platform. And this gives them the ability to migrate their on-prem workloads to the cloud. We also have Repsol. Repsol is moving key HPC workloads for scenarios like reservoir simulation and seismic interpretation. That's all being moved to the cloud. Think about HPC. HPC workloads, they require tons of compute. And if you're an HPC customer, you don't want to have to keep big compute farms on-prem, depreciating with low utilization. With the cloud, you get as much compute as you need on demand. And so the combination of Azure NetApp Files and Azure, pretty powerful combination. So now we have a video to show you. Click it.
Repsol is an energy company in 35 countries with more than 25,000 employees. We are in the process of a digital transformation to achieve our values of efficiency, sustainability, and value creation.
I've used supercomputers for the last 20 years. Most traditional reservoir engineers, they have a desktop workstation. They might get through one run a day. It's easy for a reservoir engineer to create huge volumes. Everything we'd done previously, on-premise clusters, we had workflows set up, we had licenses set up. It's now become cloud systems, it's democratization. I can now run hundreds of runs a day.
Cloud also supplies us the opportunity to deploy workstations any place in the world.
The impact that Azure HPC is having on us is the decisions are available faster.
One of the key elements that was failing during the testing was the storage. Azure NetApp Files was a lifesaver here. We have seen amazing performance increases. From simulations that took over a month to run, now are taking a few hours.
Good information allows you to optimize the position of the wells. Given that the wells are so expensive, optimizing their location and their production is extremely sensitive for our business.
The business case that we've had is billion-dollar decisions where we need to be quantitative. That means large numbers of runs, and that means an intense amount of computer power. That's what we've needed the compute capacity for. Azure HPC gives that as bursts when we need it, and the power when we need it, and where we need it.
Awesome. All right, so just to summarize, we've talked about Azure Storage. It's an exabyte scale data platform. It's optimized for global scale, hundreds of millions of transactions per second. This is a hyperscale cloud platform. We talked about our very hot tiers for object storage, for our block storage, our disk platform for files, highlighted especially Ultra Disk, unique in the industry. We have a very cost-effective archive tier. You can pre-buy storage from us and get deep discounts for your long-term data retention requirements. Talked about a single storage platform that has multiple endpoints, NFS, object storage, HDFS with ADLS Gen 2. We have a managed HPC cache service that we talked about, so you can do burst compute in the cloud from on-prem as well as with your data assets in the cloud. And then we wrapped up with NetApp ONTAP, fundamentally unique to the Microsoft Azure platform, and we're thankful for our partnership with NetApp for that one. So thank you, Yuimin, and thank you everyone for showing up.